Hello everyone, in this video we're going to go over section 9.6 class node problems. So in here we're going to be working pretty much on combinations or repetitions that are going to use the formula n plus r minus 1, choose r, or choose r out of n plus r minus 1, where this is the number of r combinations from n types, essentially. And so it's very important to understand clearly who is R and who's N. In this case, because we're talking about this, you can identify immediately the number of phi combinations with repetition from a set of 4 elements. So the the phi combinations, this means that R is going to be equals to 5 and N is going to be equals to 4. So if we apply just the formula like we just learned, we're going to get that this is 5 plus 4 minus 1, choose 5. And this is going to be 8, choose 5 at the end. And then again, a factorial over 5 factorial, 3 factorial. Which, if we find out the value, this is going to be 8 times 7 times 6 over 6. So it's going to be 56. Now we have the number of tree combinations with repetitions of a set of 6 elements. Once again, this is r equals 3, and then n is going to be equals 6. And then we apply our formula once again. This is 6 plus 3 minus 1, and then we're choosing 3. So this is a choose 3. Which, if I compute, once again, this is also going to give me 56. Remember, this is a factorial. And notice that when I get a combined 3, I'm going to get exactly the same that I got here, and that's why I'm getting exactly the same number. Okay? Getting a factorial, 3 factorial, 5 factorial. So that's why I got the same number. All right, so let's go to some exercises where it's not that clear, where they not tell me what is the combinations now that we apply the formula. So question number 2, we have a store that sells a kind of balloons with at least 30 balloons of each kind. So we want to know first how many different combinations of balloon can be chosen. So in this case, R is the once again the combinations, but we can have 30 of each kind. So R is going to be equals to 30 because that's all the possible kinds that we have. And then N is equals A, which is the type of balloon. So we're picking A plus 30 minus 1, and out of that we're picking 30. Okay, so this is from 37. From 37 we're picking up 30. And this is equivalent, just to make computations a little bit easier, this is equivalent to 37, 7. Choose 7. Remember, this is equivalent to the formula n plus r minus n minus 1. So I can replace by n minus 1, which is 7. In this case, is because it might be a little bit easier to manage if I do it this way. In any case, this is going to give me the multiplication from 37 plus 36 plus 35 plus 34 plus 32 plus 31 over, and then this is going to be 30 factorial here, which is going to cancel, and I'm going to get 7 factorial down below. And if I calculate this by calculator, this is going to be around 10,295,472. Now, let's go with a different combination. It says how many different selections include at least 13 red balance. So to fix 13 red balance, I'm going to remove those 13s out of the 30 that I'm picking. And so I'm going to have 17. So instead, now I'm not picking anymore the rest of the balance. I'm not picking 30. I'm just going to be picking 17. And so I'm picking a plus 17 minus 1, 17. So I'm going to pick from the remainder here. And because this 13 are going to be fixed, so those are going to be freely from the other 8 kinds. And this is at least 13 red balloons. So this 13 already, am I picking them red? But I can still be picking red balloons. So that's why I don't make any restrictions on this. And it's just now I have a smaller amount of balance that I get to pick from all the others. So now this is going to give me 8 plus 16 is 24. And then this is 24 combined 17, or equivalently 24 choose 7. And if you put this in your calculator or computer, this is going to be 346, 104. Now, for C, says if the store has only 12 red balloons, but at least 30 of each of the others, how many combinations of 30 balloons can be chosen? So notice that here we had at least 13, and this is the total amount of balloons that we have. So if we wanna consider the scenario where we have only 12 red balloons, we're working by the complement here. So by the complement, I'm assuming that I'm going to get the combination of these 30 balloons with only 12 red balloons. That means that I'm going to have the initial amount that I calculated, and I'm going to subtract all the possibilities that I get at least 13 balloons, since that's not going to happen because we only have 12. And so if I remove those by complement, I'm going to get 9,949,368. Okay, so we're using complement in scenario here. All right, question number 3. So we now want to know how many triplets of ijk of integer satisfy the condition that I is less than j less than k, where those numbers being between 1 and 5. Okay, so here we're choosing non-decreasing triplets from 1 to 3 to 5. So we're pretty much I, j, k can belong to 1, 2, 3, 4, 5. And so this is equivalent to choosing, since we're choosing triplets, we're choosing 3 elements with repetitions out of these 5 types. Okay? Since we're picking a triplet. So this is going to be 5 plus 3 minus 1, and then choose 3. And now this is equivalent to 8 minus 1, 7, choose 3. Okay? Which is going to be around 35. It's going to be 35. Now we do the same thing, but now we're choosing up to being 6. So we're just increasing that ijk can go up to 6. So it's the same thing, but now instead of being r equals 5, r is going to be equals 6, and we have 6 plus 3 minus 1, choose 6. And this is, once again, 8, choose 6, which is, sorry, no 6, 3. We're choosing a triplet. And so A choose 3 is going to be 56. That's shown up a couple times. And in general, the general formula here, if we have that I, j, k is between 1 and n, of course, then we get to pick the triplet out of n plus 3 minus 1, or pretty much from n plus 2, choose 3. All right, so that was another example here. The obvious important thing is that we always need to encounter how are the R combinations and who's in. That's essentially the whole trick of working with these elements. Now, for question number 4, we have some of the equations. So we want to find the number of solutions to the given equation satisfying the condition. And so we have first x1, x2 plus x3 equals 20 when xi is a non-negative integer. So in this case, we can say that xi is bigger than 0. We're considering that. Once again, then in this case, n is going to be 20, which is going to be how many ways we can approach this. Sorry, n is going to be n is going to be 3, since it's the number of ways that we add up to this. So n is the last variable here, and r is 20, which is the way that I can get combinations to get up to 20. So now this will be 20 plus 3 minus 1, and then choose 20. Or instead, because it's easier to calculate, I can go with 22. But instead of using 20, I'm going to use n minus 1, which is 2. And so if I compute this, this is going to give me 22 factorial. 22 factorial. 2 factorial, 20 factorial, which can be seen as 22 times 21 over just 2, which is going to be 231. All right, so same thing here, but we have that x1, x2, x3 is equals 20, where hxi is a positive integer. So if it's positive integer, then xi here gotta be bigger or equals than 1. So we need to make a change. So we need to make the change because this theorem that we have is for when xi is equals to 0. So we're going to make a change of variables. We're going to say yi is going to be xi minus 1. So in that way, that's going to be bigger than 0. Now, if I do that, then I'm going to transform this. I'm going to subtract 1, x1 minus 1 plus x2 minus 1 plus x3 minus 1, bigger or equals than 20 minus 3. And so now I'm subtracting 3 times 1. And so this becomes y1 plus y2 plus y3, bigger or equal than 17. And so at this point, sorry, no bigger or equal, equals. This is not an equal equation. This is not the equation is equals. Equals 20 minus 3 equals 17. So now the number of combinations will be, of course, 70 plus 3 minus 1 out of 17. Or this will be 19 combined 17. Or 19 combined 2 is the equivalent. If I compute this by my calculator, I'm going to get that this is around or equal to 171. Okay, so this is for the equations of this type. Now, let's do this, but generalize a little bit more. Notice that I can have this with more equations, like more variables. I have up to x4. And so that's not going to change too much. Here, we're going to have that we have n equals 4. And then we have r equals 12, right? So our combination is just going to be 12 plus 4 minus 1. And combine 4 minus 1. Okay, so this is 15 combine 3. And if I do this with my calculator, this is 455. Now, similar thing here, x1, x2, x3, x4 equals 20. But we have that x1 is bigger than 2, x2 is bigger than 0, x3 is bigger than 1, and x4 is bigger than 3. So I need to do different transformations for each of them. So, for example, I'm going to do y1. Since I need that y1 is bigger than 0, I need to just subtract x1 by 2. And so that's going to give me that is bigger than 0. x2 doesn't need any change. It's fine. x3, so we're going to, sorry. So we don't need to change it at all, but we're going to transform everything to y. So y2 is equals x2, bigger or equals than 0. Y3 is going to be x3 minus 1. Since that will make it bigger or equal than 0. And then y4 will be x4 minus 3. So that will be bigger or equal than 0. And so now the sum, if I do x1 plus x2 plus x3 plus x4 equals 20, then I subtract what I need. I get x1 minus 2 plus x2 plus x3 minus 1 plus x4 minus 3. I'm going to subtract the same amount of numbers on the other side. So minus 2, minus 3, minus 6. So I'm going to get y1 plus y2 plus y3 plus y4 equals 14. And so with that, I can compute the result. For the result, this is just going to be, okay, n is equals 4. R is going to be 14. So I have 14 plus 4 minus 1, 4 minus 1. And so that's equivalent to 17, choose 3. And if I put this in my calculator, this is going to be equivalent to 680. All right. So that concludes working with combinations and repetitions.